Hello, everyone, and welcome to today's webinar with VoltDB and Comviva, Effectively Target MicroMoments with Real-Time Decisioning and Machine Learning. We appreciate you taking the time out of your schedule to join us for today's presentation. This webinar will feature insights from Greg Armstrong, Head of Product Management, Consumer Value Solutions at Comviva, and Sita Somagani, Director of Field Engineering at VoltDB. Before we get started, I'd like to go over a few items so you know how to participate in today's event. You will have the opportunity to submit text questions to our presenters by typing your questions into the questions pane of the control panel. You may send in your questions at any time during the presentation. We will collect these and address them during the Q&A session at the end of today's presentation. If for any reason you are unable to get to any of the questions asked, our presenters will follow up with you directly via email after the webinar. Now, without further ado, I would like to introduce Sita Somagani to kick things off.
Thanks, Bob. So first of all, good morning, good afternoon, or good evening. So Greg and I today will be speaking about effectively targeting micro-moments with real-time decisioning and machine learning. So I'd like to thank Greg and Comviva for being an excellent partner with us and giving us the opportunity to highlight an ideal use case for VoltDB while demonstrating the capabilities of Comviva's own product as a complete solution. So quick introduction to VoltDB as a company, founded in 2009 by Dr. Michael Stonebraker, sometimes known as the father of the modern databases. And to his credit, he has other databases that he created: Ingress, Postgres, Vertica, and Streambase. And we have customers in major companies all over the world, and our success as the database for high performance applications is reflected in these real life use cases. Whether it is high performance in telco, gaming, car auctions, or financial trading, VoltDB has proven itself to be a versatile platform. And we have a bunch of benchmarks that we ran demonstrating that VoltDB is one of the fastest databases on the market today. So while VoltDB is versatile across many industries and verticals, it is actually quite a specialized database that Dr. Stonebraker created while he was at Vertica as the counterpart to the analytical database that Vertica is. So Volt is a transactional database and Vertica is the analytical database. And our product is available both as open source and enterprise versions. I'd like to pass on to Greg.
Thank you, Sita, and hello, everyone. Good morning, afternoon, or evening, wherever you happen to be in the world. Just in terms of a little bit about Comviva, before I turn back to Sita. We are a wholly owned subsidiary of Tech Mahindra and part of the Mahindra Group family. We've got around 2 billion users using our platforms globally. We're specialists in primarily in communications and in financial services industries. We're serving over 95 countries. There's about 2,000 Comvivians in the organization. We're the world's largest provider of digital wallet and payment platform services, capabilities and services, and we've got about 50 plus patents that have been filed. So that's a little bit about Comviva. I'll turn back to Sita and then I'll talk again to you in a little while.
Thanks, Greg. So to kick things off, I would like to introduce or reintroduce the paradigm of stateful stream processing, which is basically taking business events and turning them into decisions in real time, but using the intelligence and the context of. So the advantage that you can gain from stateful stream processing could be that there are lots of business opportunities. There could be tiny fleeting windows of opportunity where your business might need to make an offer to a customer or maybe detect even a fraudulent activity. So it's both an advantage to take advantage to use these micro moments or these small business events, and also it's imperative in some cases. So stateful stream processing essentially brings the mutable state, context, analytics, and intelligence into the real-time processing pipeline. Now, what do we mean by mutable state? It's the accurate representation of the state as it relates to perhaps the customer at hand. How long has this customer been on the phone, and or how many calls has he made in the last 1 hour? That can be reflected in the mutable state and the context. And the analytics of how you might segment this customer in an online or offline analytical process, and the intelligence that can be imported from your machine learning pipeline. Being able to use this state and intelligence in real-time processing is what the stateful stream processing paradigm puts forward. And how do we implement such a paradigm? So the crux of it, we believe, is being able to take smart decisions. And the ACID requirement sits at the top as we see it, because on outdated information. These windows should be handled immediately per event as they come in, and they could be missed if you are using a batch or a micro-batched processing model. So once you understand the necessity of processing your events in a consistent ACID requirement manner, then we can see how exactly are you going to make these decisions. So WorldDB provides stored procedures. This might not sound like an exciting term if you're already familiar with traditional databases, but the convenience of writing a stored procedure that is run as a transaction over a distributed database can be pretty amazing. So this stored procedure you can write using a combination of SQL and Java, or just simply SQL. You could choose to write your own functions to enrich the SQL language, or use our geospatial in addition to many other specific functions that we provide to give you the expressibility of writing a complex processing. So you are able to run complex process. You are able to perform the complex process with ACID guarantees. So what would you use to perform this complex process? So as stateful stream processing dictates, you would use the mutable state, which is provided by Volt using partition tables. I'll get a bit deeper into what partition tables are and how they are advantageous, but quickly, partition tables essentially are tables that are distributed across many machines, or distributed even in one machine across multiple cores. This allows you to hold mutable state that can grow, because you can add more nodes to increase the capacity, or you can add more nodes to increase the throughput of your application according to what your application's workload is. And the context, such as what are the hotspots of my network, or what apps are being used more often during the last 1 hour, or at a certain geographical location. This context is provided by materialized views. And now materialized views are also a concept that is borrowed from the traditional databases, but in the context of Volt, materialized views are sort of like a continuously running query where you define a materialized view as a join on multiple tables, and you are able to have accurate and transactional access to this context. Now, the cost of computing these aggregates, such as, well, let me add up how many users are currently active in a certain geographical point right now, that can be very costly if you have to go through every single user and calculate that. With a materialized view, though, the cost of these aggregations rather is amortized over the individual inserts and updates that you are making to the underlying state of the partition tables. So together, the mutable state and the context provide you the latest view of your data on a very fast changing data. If we look at the analytics, though, this is a more broader, a slower, and offline processing of your data that is performed perhaps in a different OLAP database, where you segment your users or derive some coefficients, thresholds, or offsets that you can import back into Volt so that you can use these analytics for your decisions as part of your stored procedure. Now, same thing with the machine learning as well. You could take a machine learning model that was trained elsewhere in your machine learning pipeline, and if that model is exported as a PMML, then you could import that into Volt and use that model to through your stored procedures execution. So the smart decisioning is essentially being able to put this complex logic in a consistent, under this consistency, asset consistency requirements, and combining the fast changing state and context with slower changing analytics and machine learning model to take effective decisions in real time. That's what enables VoltDB. That's how VoltDB supports applications such as Mobilitex. Now, this power and smartness only goes certain distance, but you would also have to be able to scale your applications, scale your deployments, and make it easy for applications to be deployed. So VoltDB being an inherently distributed database, even within a single node, you can view Volt as a distributed database because you are partitioning by the core. If you have 24 core server, you could have 24 partitions, effectively parallelizing your workload over those 24 partitions. That allows VoltDB to easily scale from out and in elastically over clusters of different sizes. If you had a 5-node cluster, you could scale out to a 7-node cluster or scale down to a 3-node cluster based on the distribution of your workload. So that's within a single data center. And for multiple data centers, VoltDB supports active and active passive data center replication. So you could have multiple clusters in different data centers distributed in a wide geographic area, maybe between continents or countries, and have them communicate with each other and stay in sync to a lesser guarantees than in inter-cluster replication, but you can still take advantage of cross-data center replication to say perhaps you would like to provide an edge processing model. So users can connect to a data center that's geographically closer to them and get a better service for things such as, let's say, a family plan, a family subscription plan where the family members could be distributed in different places, but they would all be sharing the same number of minutes that are allocated to them, and you would like to keep an accurate count. So these situations are something that you can easily solve with VoltDB using the built-in active-active cross-data center replication without breaking a sweat. Now, we've seen the smartness that is required and the ease that is required and how VoltDB provides those, but how about why is VoltDB fast? What makes VoltDB fast? We can start at the data ingestion part of it. We need to be able to ingest a massive number of events, massive flows of data into Volt without any bottlenecks. So Volt is a shared nothing peer-to-peer architecture. So the events are sent from the client directly to the partition, not just to the server, directly to the partition that they're supposed to end up in. And this prevents having any bottlenecks, such as what you might find in a master-slave architecture. So you can see the events going into individual partitions, whether that's events or database calls, each goes to the appropriate partition. And what happens after that? What happens after this event is ingested? To process this event, we need to perhaps maybe make updates to the state, make updates to the context, or maybe read from the context, maybe read from your machine learning model. How do we implement those operations without bottlenecks? So this is where Dr. Stonebreaker's seminal white paper about the traditional OLTP databases comes into picture here. So he said, in the traditional databases, the typical processing time, 90% of it is spent in overhead. It's actually spent in overhead and not the actual processing of the transaction. That is because these databases were written back in 1970s using a model which does not make sense today, whether that is due to the changed hardware or due to the changed data patterns, data processing needs. Those databases spend a lot of time in the overhead. And VoltDB being written from the ground up, from scratch, to avoid locking, latching, and buffer management, that takes out like 70% of the overhead right there. We're able to do that because VoltDB is in memory. It does not read and write to disk, but it is able to provide fast durability. So every transaction that you run on Volt is durable to disk. In case of the machine going down, you can recover those transactions, rerun them, and restore the state of your database. You also have the capability of running transactions in a synchronous or an asynchronous manner to get higher throughput. So a distributed database without the traditional bottlenecks that you find in a traditional database and being 100% in memory enables Volt to provide this high performance and high throughput. So to get to my last slide, here I'm trying to depict a high-level architecture of Volt and the execution model of transaction. So you see two boxes at the highest level. There's a box VoltDB and there is a data pipeline box. So let's focus on the data pipeline. Here you would see the technologies that you can use to integrate with Volt. If you have your messages streaming in through Kafka, we have a Kafka importer that uses the import streams component of Volt to push data into Volt. Or you could use a JDBC loader or use one of our language SDKs such as Java, C, C++, Python, Golang. All the popular languages are supported. Or you could integrate other systems to Volt such a way that Volt is able to push the data or the events down to these systems such as Hadoop or Elasticsearch. So here, if we look at the integration between the other technologies that are part of your data pipeline with Volt, it's not just a matter of integrations, but rather how are we providing this integration in a fail-safe manner and provide you some sort of semantics that you can depend on, like exactly once semantics or at least once semantics that you can depend on to maybe handle some errors. So if the downstream database, let's just assume, say it's a SQL Server database and it's not able to keep up with Volt, then Volt will manage the buffering of the export records so that the SQL Server can catch up over time in the case of spikes in the throughput. Or if it's down, you can work on bringing it back up while being ensured that the data is not lost. It is managed by Volt. And if Volt wants to put back pressure on Kafka, it has that capability as well, and saying Kafka and limiting Kafka to a certain throughput that it is able to handle. So being able to provide this flow control and the semantics and the fail-safe, failure-resistant capabilities, Volt is not just a powerful tool by itself, but it also works well with the other technologies and tools in your data pipeline. Now, if we focus on the VoltDB box, you can see that we are depicting here a database of 3 clusters, node A, B, and C. These could be physical servers or virtual machines, doesn't matter. And we've blown up the node C so that we can see inside of it. And there are multiple partitions. So each node has multiple partitions, which are processing units by themselves, processing plus storage units by themselves. We have, say, partitions 1, 2, through to N. And we blew up partition N, in which you can see that the database calls or import events, they are being ingested as transactions, and each transaction comes one after the other. So Volt supports the highest level of isolation, which is strong serializability, that allows Volt to keep things simple and provide you the best performance. So what's a transaction? What is involved in this transaction? That's where the most interest lies and most of the complexity lies. Is first we ensure the transaction is durable to disk, which is simply we're writing the transaction to disk rather than a binary difference of data. This is to ensure that quickly we're doing the minimum amount of work to make our transaction durable and support ACID, and relegating the other parts, such as capturing a snapshot of data, to a slower and kind of an offline thread. So your transactions are executed really, really fast. So once it's durable, you're also executing the procedure, and the execution of the procedure takes the form of a stored procedure. And in your stored procedure, you could be using a machine learning model that you had imported, and a bunch of SQL statements and Java conditional logic. Now this logic can, or in the SQL statements, they can use the tables, their own partition tables, their own state. So for this particular user that this event was generated from, what's his state? And what's the context, maybe a wider context of users in this geographic area or users in this segment? What's the context? You can take that into account by accessing the materialized views. And that is a very accurate context, because all of this falls within the transaction. And you can see that the other partitions are also writing to the materialized views or accessing the materialized views, so that you have the context across the entire database. So making the database transaction durable and executing the stored procedure using the state that is represented in your partition tables, your replicated tables, the materialized views, and also using the machine learning models. Now that represents being able to take a smart and consistent decision at a high throughput on your streaming data. So in a sense, I think I hope I was able to relay how WorldDB implements at the highest level a stateful stream processing platform. So with that, now I hand this off to Greg.
Thanks, Sita. And now I'll try and do a reasonable job of explaining how we use VoltDB to support the implementation of our Mobilitics product, which is a real-time marketing automation and analytics platform. So if you don't mind just going to the next slide. We've got three driving themes behind our product development, our product roadmap, which I just want to quickly talk about before I move on to the actual product itself. The first of those is to leverage MicroMoments. Now, MicroMoments is a term coined by Google. It's certainly not ours, but it's just recognizing the shift in consumer behavior that's taken place as a consequence of mobile device ubiquity, and also the fact the internet's everywhere as well. And that basically it means that there are moments on these devices or at time when customers are looking to find, buy, or do something. And that basically, if you want to influence those moments, you need to be able to act in real time. You need to be able to make decisions about whether or not to target someone with an offer, and if so, the offer to target. And generally that means it needs to be done in sub-second time, particularly if you're on a digital channel. Those MicroMoments might be things like researching devices online, and these are examples from the communications industry. It could be you're researching mobile plans. Maybe it's going through the process of activating a SIM. It could be buying a recharge. It could be the fact you're running out of real airtime and there's a low balance. You know, you're running out of airtime very soon, or you're running out of data. All these sorts of things represent MicroMoments. So the first one is leveraging MicroMoments and recognizing that real time matters because of that. You know, a few minutes is too late. If we go to the next slide, the second theme is about delivering digital enablement and in the cloud. So digital enablement means being able to ingest and use digital data, and obviously it can be in extremely large volumes of streaming data coming in. The second is being able to integrate with and communicate through digital channels. And the second element of this, in terms of our driving theme, is to ensure that our application works both in-premise and in the cloud. The final theme, if you don't mind moving to the next slide, is to harness the power of machine learning, predictive and prescriptive analytics. And this is all about using modeling and machine learning modeling in particular to aid decisions about whether or not to make an offer, and again, which offer to make, as well as building out the profile of the customer base. If we could move to the next slide. There are sort of three core building blocks to Mobalytics. The first of these is what we call our behavioral DNA. This is the other names, 360-degree profile, customer context record, but basically represents features that represent your customer. In the telco market, we've got a behavioral DNA dictionary of about 1,600 features, and that's continually growing. So the heart of this is the behavioral DNA. On the left-hand side of this diagram, you see the analytics platform. Its role, among other things, is to enrich the behavioral DNA with analytics. So this could be in the terms of propensity scores. It could be a churn propensity score. It could be a propensity to be upsold. It could be, again, if you take the telco market, it could be on the basis of a propensity to be a multi-simmer. But these can be propensities to respond on a particular channel. Maybe email, SMS, or through the app, or through some other channel. So it can be propensity scores. It can also be scores sort of developed by NBO models, where you're predicting the likelihood of a particular offer to result in a behavior that you're after, whether it be an increase in revenue, increase in life of the customer, uptake of a particular service. So that's where the analytics platform can come in. And then on the right-hand side is the real-time decisioning component. And in Mobalytics, this is where we run on VoltDB. So basically, it's taking that rich profile, real-time, near real-time events, using those to make decisions on an offer, whether or not to target someone with an offer, and if so, which one it's to be, and also managing the orchestrating the sort of the interaction with the customer. If we go on to the next slide. Here is our architecture diagram of Mobalytics, and I'll use this to explain how the platform works and the role of VoltDB. In the center is the Mobalytics real-time marketing platform. It follows the Lambda architecture for real-time decisioning, and it's got sort of the top part is the in-memory layer. That's where VoltDB sits. The bottom part is the batch layer, typically Postgres or Oracle database. And then there's basically the serving layer, which is serving the channels, communications, receiving communications, managing integration with fulfillment engines or perhaps other APIs and other third-party applications. The little box to the left is where the AI platform fits, and I'll describe each of these components in a little more detail now. So we'll start with the bottom part of the picture, which is the batch layer. So here, typically, we're receiving high latency data, and it's received typically on a daily basis, and it's generally profile data coming from often data warehouses, data lakes, could be direct source systems, but generally coming from some data warehousing infrastructure. That represents if you like, the bulk of building up the behavioral DNA, the starting point of it. Within the analytics platform, the contextual analytics platform, we can take those profiles and build out various aggregations and views of the customer profile. and we generate the behavioral DNA in there. It's also a storing of data marts for reporting and analysis. But the heart of it is the behavioral DNA. At the top layer is the in-memory layer, and there are 4 core modules. The first of these we call event detection. This is the module that receives the real-time or near real-time events. I say near real-time because often we're still getting files, data files sent to us in 5 or 15-minute intervals. It's not always that the source systems have APIs that are able to be exposed or accessed for getting streaming data. It just depends on the source system. But that data is received, and the role of the event detection module is to make a decision on whether or not the event is one we want to action or whether it's one we want to discard. So, for example, you may want to discard it because the customer's already got an offer. You may want to discard it because your contact policy will be breached. Those would be typical examples of why you wouldn't want to process an event. But if you do want to process the event, you do want to do something with it, it goes to the next module, which is our offer allocation module. The offer allocation module is there, its primary role is to determine if there is an offer or offers to present to the customer and to select them. There's 3 core processes in here. One is associated with dynamic segmentation. A second is to retrieve all eligible offers. There could be an offer catalog, could have 1, could have 10, could have 100, could have 1,000 offers in it. So it's retrieving the eligible offers. And the third process is to select the offer or offers to present to the customer. That's typically where the outputs of sort of NBO models are used, scoring offers which can be used, as well as contextual information like someone's current balance to determine which offer to present to the customer. If there is an offer to present and there's not always an offer, you don't want to present offers, for example, to customers where perhaps where you expect them to behave the way you're looking for anyway. Well, there may be no eligible offer for them at this time, but if there is an eligible offer, it goes to the next module, which we call workflow execution. And this is the module which orchestrates the communication with the customer through the communication channels, which can be a variety of legacy or digital channels. Basically, this also listens for the customer to do the behavior that you're asking them to do, which might be to buy a service, maybe to visit a particular website or location. It could be to top up, it could be to subscribe to a service, it could be to buy a bundle, it could be to spend money on a credit card. Whatever the action is, the workflow execution engine is listening for that. Often those events are received as an event on the left-hand side and coming through event detection, but we're listening for the events for the customer to actually behave, and then we would fulfill any reward or product for the customer that is part of that offer. So those are the 3 core modules that work across from an event being received to an offer being allocated. The 4th module in there, the inbound request manager, is there to manage synchronous sessions associated with when you receive requests for offers from inbound channels. For example, someone going to the self-care app of a communications provider or a bank and retrieving offers to present to them. The thing is that in that scenario, that's where you really do need to be able to operate sub-second. We've got a client where, for example, the customer goes to the recharge app, to the self-care app, goes to recharge. We've got about 400 milliseconds in which we need to return an offer to that customer to try and get them to stretch the amount they would normally buy. And we've only got 400 milliseconds because if it takes longer than that, the app continues its journey along the recharge path, because you obviously don't want to compromise your ability to get the recharge revenue. So those are that inbound request manager is basically there. We expose APIs, we receive requests for offers, and it is able to make decisions about whether an offer should be returned or not. And if it is to be returned, then it makes a call to offer allocation to get the offer and send it back to the inbound channel. Typically, the end-to-end journey time from an event being received to the communication to the customer, it can be as little as a few hundred milliseconds, or it can be several seconds, and it really depends on the channel. And you tune the sort of the throughput to recognize what you need for a particular channel. So when you're sending an offer out via SMS, it doesn't have to take half a second to get through the application. It can take several seconds, and you haven't compromised customer experience. But as I said, if it's a digital channel, particularly if it's an inbound request, you just have to return the offer within a few hundred milliseconds. So that's the sort of the platform, the Mobalytics real-time marketing platform. The AI platform is basically the platform where AI models are basically built. So the platform can receive structured and unstructured data. It's got a capability around data acquisition, feature engineering, data exploration, model development, evaluation, and then deployment, and then running in production. When running in production, it can either be run as a batch process, in which case there's updates to the behavioral DNA, or it can be called, the models can be called in real time. The link between the batch layer and the real-time layer is the behavioral DNA, which is populated into memory. So when you're configuring a use case or a campaign in the in-memory layer, you choose the behavioral DNA that you want as part of that use case, and that's the data which is populated in memory. We only bring up the data into memory that we need at the time. The other thing I should state is that when you're receiving real-time or near real-time events, we update the behavioral DNA in real time as well. So real time means two things for us. One is the time between an event occurring and a communication with an offer being able to send to a customer. And the second is the time from a change of the customer's profile happening and it actually being recognized in our behavioral DNA. So for example, making a tariff change or updating the date of the last recharge or the value of the last recharge. So that's sort of an overview of the platform. And I think I can probably stop there, I think, in terms of the overview of the platform, Sita, and turn it back to you.
Thanks, Greg. So I hope we have given an understanding of how WorldDB supports these real-time transactions, being able to take these intelligent decisions in real time, particular in context to how you would do that with making the offers, as in the case of Mobalytics, but you can extrapolate that to other industries as well. So hopefully you derived some value out of this webinar, and we'd like to thank you again for joining us today. Back to Bob.
Thanks, Sita. Yes, we do have a few questions that came in during today's presentation. Also, you can continue to submit questions through the Q&A through the questions panel in the the questions tab in the control panel. This first one is actually for Greg. It is, what industries is Comviva operating in?
Thanks, Bob. So today, our focus has been in communications, and recently moving into banking and financial services. So that's our heritage. The platform itself is not industry specific. The things that really change when you're moving between industries is the behavioral DNA dictionary, because that has to be industry specific. and the integration points and the sort of external events that we would use and integrate with. But historically, we've been in communications and moving into banking.
Okay, great. Yeah, so we have a few here, and I'll just alternate. It looks like a few for Comviva, a few for CETA and VoltDB. So next one, CETA. How does VoltDB differentiate from other database platforms?
So there are a lot of database platforms out there today, and I think it's a very significant challenge in, to understand where VoltDB can be a fit, and what technology might be the best for you guys. So typically, we are compared against the traditional databases because VoltDB in itself is a relational database. The comparison with traditional databases is done very often. But the main difference with Volt is that it's written from the ground up, from scratch. It is not meant to do everything in one database. When your data processing strategy expands from, say, let's put everything in Oracle and maybe another data warehouse, and let's try to do transactions in one and analytics in the other, expand to tier your database layer and handle the most important and most critical events as soon as they occur and handle them right away. VoltDB plays a big part in that area. So if you have a high throughput, high performance application that requires consistent decision making at the time of ingestion of the event, so you want to make the right decision at the right time, that's probably where VoltDB is a great fit.
Awesome. Okay, Greg, this one is for you. What sort of gains or benefits are people getting out of the MobileLinux platform?
Thanks. This is a good question and never an easy one to answer. Often we're, as a sort of supplier of capabilities, we're not necessarily privy to all this information from our clients. And when you talk about comparatives, it's always challenging with different markets and different methodologies for doing those comparisons. But we have, just to give you a bit of an idea, we have got a client who is consistently getting incremental revenue returns of around 2.5% a month. And this is very robustly measured. This is basically a universal target group versus a universal control group. So taking all the revenue you've made from your target group in a month, subtracting from that the scaled up revenue, scaling up the revenue from your control group, and that that then represents the net incremental revenue. And so that that's and this is in a pretty developed market. So I know that one I feel very confident about. There's other examples I think where demonstrating the power of machine learning and real-time information is a situation with a program where moving from business rules, sort of marketing intuition-based business rules, to using modeling to predict offer uptake and using a real-time balance check has increased the conversion rate of a program by about 7-fold. It was low single digits, mid-single digits, and ended up being 30-odd%. And also the participation rate in the program grew dramatically, about 3 times, which indicates that customers were getting a lot more value out of it. So I think those are two pretty good examples. We also have done some benchmarking of looking at the comparative performance of triggering campaigns off real-time events versus using sort of traditional batch planned campaigns, and we saw a significant improvement in performance. So that got us to a point where we believe that being at the right time is probably is very useful in getting a next step of performance in CVM campaigns. The one after that is when you're basically looking at how you make sure that you're improving your decisioning around what to offer.
Great. That's awesome. Another one that just came in, what is the vision for VoltDB in the coming days? Are things like expansion towards CDP or maybe prescriptive analytics planned?
So as a technology company and being relatively industry agnostic, we'd like to stay out of anything specific to any industry. But I can talk a little bit about our vision for the future. And we've started as a very solid relational database that offers all the guarantees that you come to expect from a traditional database, but at the speed of NoSQL. So the guarantees of traditional database, but the speed of NoSQL combined together as a new SQL WorldDB database. So as we have progressed through over multiple iterations of the product, we've added many benefits, but again, our roadmap is taking us more and more towards more of a stream processing platform. So if you take something like Kafka, which has a very simple benefit, just being able to hold logs of events from multiple publishers to be consumed by multiple consumers, which something that WorldDB pretty much has the capability to do. So we would like to make changes and upgrades in that regard, allowing different consumers and publishers to work with WorldDB. So nothing in terms of any specific industry as such, but making it easier for you to build the platform for your own industry to be able to essentially make the right decision at the right time.
Awesome. We do have another one in. Greg, it looks like this one would be for you. It's how modular is Mobalytics as a platform? Is it possible to integrate just the decision engine with an existing marketing automation platform?
Yes, it is. It's designed to be modular. Those modules I spoke about in the architecture, we've done that deliberately and ensured that we maintain separation between them. We've got scenarios where we have got, for example, the event detection and offer allocation modules are integrated with a sort of a legacy campaign management platform for managing the orchestration with the customer.
Gotcha. Okay. We have another one that came in. What changes do you witness when creating the BDNA across industries? Is it related to the identifier, or is there something more to it? I don't know who would want to take that. Yeah.
I think that'll be for me around the BDNA. I don't have a lot of cross-industry experience. As I said, we've worked on communications, we've worked in banking. The thing that obviously it does, I mean, this is what is specific to the industry, because effectively you've got different profile attributes. I mean, there's some which are, there are some which are common, but a lot of them are actually industry specific, based around the type of service that you're selling. So it's a mixture of that. The ones that are consistent are ones that are, the attributes that are sort of customer level ones, channel, associated with channel identifiers and things like that. And also the behavioral DNA that we generate internally in the platform associated with the execution of use cases. For example, counts of offers being sent, lists of current open offers, offers that have been rejected, offers that have been accepted. But it is, as I said, it's going into different industries. It's the behavioral DNA dictionary that needs to, which differs primarily. The platform itself, the configuration of it is industry agnostic. Configuration of the use cases.
Okay, awesome. It looks like we have one more, and this one is for Sita. What are some of the key differentiators of stateful stream processing versus traditional stream processing?
Yes. So, as the name says, lack of state essentially, and I think I need to expand on what state is. In a typical stream processing solution, you can have some sort of a state wherein you have, you would have some constant or static data that could be changed, but it doesn't really mutate with each coming in event. And a lot of stream processing solutions do their processing in a micro batch manner and do not process events per event. So they lack the capability to act on every single event with a 360-degree view of the world in which that event is occurring. So although the difference might seem simple and easy to fix, it's rather something fundamental that either you are looking at the events coming in as a bunch of signals, each of which needs to be processed, or you're looking at the events coming in as opportunities, which you need to take the most advantage of, keeping in hand the full view, the full context in which these events are occurring. So the stateful stream processing takes the challenge that stream processing tries to address, which is handling a deluge of events, but doesn't lose the intelligence that you typically get from the traditional database processing. So being able to put those together, I think, can make the difference in competing in the market.
Great. Well, just looking through, it looks like that is the last of the questions, and we're kind of getting down to the time here. So I just want to thank Greg and Sita once again, and thank you all for attending today's webinar. If you have any questions, please reach out to info@voltdb.com or info@comviva.com. And just once again, on behalf of VoltDB and Comviva, thank you for joining us, and have a great rest of your day.
Thank you.
Thanks a lot, guys.